600 robots have been removed from a car assembly line, not to cut labor costs, but because Tesla believes that the assembly line no longer has a reason to exist. For more than a century, the global auto industry has relied on the same basic process: stamping, welding, painting, and final assembly. But Tesla doesn't believe the problem lies with the car itself. They believe the real problem is the factory that builds it. So, what happens if one of the most important inventions in automotive history is no longer the best way to build a car? The quiet revolution happening inside Tesla's gigafactories isn't just shaping the company's future. It could also influence the price of the next car you buy. Let's dig in. In 1913, Henry Ford introduced the first moving assembly line for the Model T. This invention transformed cars from a luxury item into something the American middle class could finally afford. More than 100 years later, most of the auto industry still follows the same basic approach: stamp metal panels, weld them into a body, paint the entire shell, and only then install the remaining components. In March 2023, at Tesla's Investor Day, Lars Moravy, Tesla's vice president of vehicle engineering, said that if the company wanted to scale production the way it envisioned, it had to completely rethink how a car is built. Tesla calls this strategy Unboxed, the foundation of what it sees as the next generation of manufacturing. If Tesla is right, this could become the biggest change in automotive manufacturing since Henry Ford. But before we understand why Tesla wants to replace the traditional assembly line, we first need to understand why a manufacturing system that has lasted for more than 100 years is beginning to reach its limits. In the traditional manufacturing process, a car has to move through 4 fixed stages in sequence: stamping, body assembly, painting, and final assembly. The problem is that if one stage runs into trouble, every stage after it is forced to wait. One of the most expensive parts of the process is the paint shop. A complete car body, usually about 1.8 meters wide and more than 4.5 meters long, has to travel through the entire paint facility, even when only a few small metal panels actually need to be painted. That means an entire production system has to keep running just to process a small portion of the vehicle. Instead of trying to improve each individual step, Tesla went back to a much more fundamental question. Why do we need to weld hundreds of separate metal pieces together in the first place? This is the first principles way of thinking that Elon Musk often talks about. From that question came 3 guiding principles that would shape nearly every manufacturing decision Tesla made afterward. Reduce the number of parts. Reduce the number of manufacturing steps. Reduce the size of the factory. It sounds simple, but turning those 3 principles into reality had to begin in the casting shop, where Tesla needed a machine powerful enough to replace hundreds of individual parts with a single casting. Tesla's answer was a gigantic machine called the Giga Press. It is a high-pressure die-casting machine weighing around 410 tons and stretching nearly 20 meters long. It generates roughly 6,000 tons of clamping force, enough to inject molten aluminum into a mold in just an instant. The result is remarkable. The rear underbody of the Model Y, which once required 171 separate metal parts welded together, is now made as a single cast component. Tesla has also applied the same philosophy to other production lines, eliminating around 600 robots from certain assembly processes. According to independent industry analysis, the manufacturing cost of the Model Y's rear underbody has been reduced by about 40%. But this technology doesn't come cheap. Each casting mold costs millions of dollars, and that investment only makes financial sense when you're producing hundreds of thousands or even millions of vehicles. on the same platform. And that's not the only trade-off. According to Monroe and Associates, a company specializing in automotive engineering analysis, the thinner sections of large castings may allow moisture to penetrate if they are not properly designed and manufactured. Reducing the number of parts in the vehicle's structure was only the first step. Before the body moved on to the next stage of production, another component had already been quietly transformed beneath the floor of the car: the battery. The interesting thing is that Tesla didn't redesign the battery pack to make the car drive farther. They did it to make the factory build the car more simply. Tesla developed the 4680 battery cell, not just to improve efficiency, but to make a new design possible: the structural battery pack. Instead of being just a battery pack mounted beneath the floor, the entire battery pack now becomes a structural part of the vehicle, serving as the floor of the car itself. Even the front seats are mounted directly onto the battery pack instead of onto a separate floor panel like in a traditional car. This allows Tesla to eliminate an entire floor structure, reduce the number of parts, increase chassis stiffness, and lower the vehicle's overall weight. For the first time in one of Tesla's mass-produced vehicles, a component whose only job was once to store energy has become part of the car's structural frame. But the trade-offs were significant. For years, scaling up production of the 4680 cell was one of Tesla's biggest manufacturing challenges. The company had to build an almost entirely new battery production process, and actual production volumes fell well short of its original expectations. By this point, both the vehicle's structure and its battery pack had been simplified as much as possible. And in the next stage, Tesla was about to take an even more radical step, replacing the traditional long assembly line used by virtually every other car factory. Once the vehicle's structure and battery pack had been simplified as much as possible, Tesla asked one final question: do we still need a long assembly line where everything has to happen in a fixed sequence? Their answer was Unboxed, built around a concept called delayed 3D. The idea is to keep components in their flat, two-dimensional form for as long as possible, and only assemble them into a complete vehicle at the very end. This completely reverses the traditional process. In the past, the doors, hood, and tailgate were attached to the body before the entire vehicle was sent through the paint shop. With Unboxed, those panels are painted separately first, then installed only after the interior has been fully assembled. The robots are organized differently as well. Instead of lining up along one long assembly line, each group of robots works on a separate module. Those modules are brought together only in the final stage. Tesla believes this approach could eliminate more than 100 stamping and welding steps, while cutting production costs by as much as 50%. Bloomberg Intelligence, however, offers a more conservative estimate of around 33%. On paper, Unboxed looks almost like the perfect solution. But every new manufacturing idea has to prove itself on a real factory floor. And Cybertruck became the first real test. Cybertruck was the first vehicle where Tesla deployed large-scale gigacasting on its most ambitious scale yet. It became the proving ground for the company's Unboxed vision before expanding the concept more broadly. So if Giga Press and Unboxed are so effective, why haven't companies like Toyota, BMW, or Mercedes-Benz adopted them already? It's not because they don't know about the technology. There are several reasons why traditional automakers remain cautious. Each Giga Press requires an enormous upfront investment, while existing production lines have been refined over decades and are still highly efficient. More importantly, most automakers build many different vehicle models in varying production volumes, making the benefits of Giga casting far less compelling than they are for Tesla. In addition, many engineers have raised questions about crash repairs, since replacing or repairing a large one-piece casting can be much more difficult than repairing a traditional multi-piece structure. Tesla itself has not been immune to these challenges. According to Reuters, the company once considered using large one-piece castings for a future low-cost electric vehicle. However, the plan reportedly ran into significant manufacturing and cost challenges, forcing Tesla to rethink that approach. Tesla has shown that a different way of building cars is possible. But before the rest of the industry follows, it still has to prove that this approach is sustainable, flexible, and capable of scaling over the coming decades. The important question isn't whether Tesla will succeed. It's this: if this manufacturing model truly works, what happens next? The three principles Tesla follows — reduce parts, reduce manufacturing steps, and reduce factory size — aren't just for the automotive industry. Many other industries, from home appliances to industrial robotics, face the same challenge. Too many components, too many production steps, and too much factory space. What's truly interesting isn't whether other industries will copy the Giga Press or the Unboxed process. It's the way Tesla went back to the most fundamental question. Why are we still building things the same way we've done for more than a century? Perhaps the competition of the future won't be about who builds the better car. It will also be about who finds the most efficient way to build it. More than 100 years ago, Henry Ford changed the world with the moving assembly line. More than a century later, Tesla is asking whether that assembly line still needs to exist. Not every first principles idea survives the realities of a working factory. But if this one does, it could redefine how industrial products are made in the future. Not just the cars we drive, but the very way we think about manufacturing itself.